All right, guys, let's take a look at this example over here. So this example is actually coming from your, as you can see, section 8.1, and this is specifically about the mean and standard deviation of the sampling distribution of X bar. So you can see this is page 370 of your textbook. So I just kind of wanted to show you, some of the formulas over here. So you can see the mu of X over here, the mean for the sampling distribution is actually going to be the same as the population mean. So it's going to equal the population mean. You can see that right over here. And your standard deviation for the sampling distribution is defined as the standard deviation for your population divided by square root of n, where n is, of course, the size of your random sample. And we describe X bar, which is the mean for the sampling distribution, as the standard error of the mean. Now, one thing you have to keep in mind is that your sample size, you can kind of see this little box of caution over here. They are telling you, you can see two important assumptions you have to make that are satisfied, when you're working with these types of examples, is that your sample must be a random sample and that your sample values must be independent when sampling without replacement, which is what happens when you're looking at simple random samples. You have to verify that your sample size is less than 5% of the population size. Okay, so that's one thing you have to think about. So let's go back to our problem over here. Okay, so here you can see they are telling us that the random sample size is 13. Our population mean is 67, standard deviation is 19. Now, the first question is asking, what must be true regarding the distribution of the population in order to use the normal model, to compute these probabilities regarding the sample mean. So basically, you should either have a large sample size that, if you have a normal model or not, or if it's normally distributed, does not make a difference. Or if your sample size is small, then you should have a normally distributed population. So as you can see, the four options that we are given over here, they're saying there are no requirements on the shape of the distribution. That's not correct. Since the sample size is large enough, the population does not need to be normal. Well, our sample size is not very large. It's just n equals 13. So it wouldn't be option B either. The population must be normally distributed. That guy's looking good. The population must be normally distributed and the sample size must be large. You don't need to have both. So it's going to be option C. We'll do a quick check there. Okay, now they're asking you, assuming the normal model can be used, describe the sampling distribution for X bar. So this is what I was showing you over here. So you can see how you have the sampling mean equal to the population mean. Oops. And of course, like I was showing you again, the standard deviation being the standard deviation for the population divided by square root of n. So if you keep those in mind, you should be able to come up with these two options. So let's clear out some of these. So remember, your sampling mean is equal to your population mean, which in our case will be 67. And then your standard deviation for the sampling distribution is population standard deviation divided by square root of n. So our population standard deviation is 19. Square root of n will be square root of 13. So you can see, once you write these out, the only option that will be correct is going to be option A. So that's the one we're going to choose. Check. You should be good to go. Alrighty, then we get into the calculation part. So this one you can see is given to us as P of X bar is less than 71.3. Okay, I'm going to show you from the textbook page again. So it's actually going to be this formula that you're kind of seeing down here, but just a little modified. So I kind of like this example, how they're showing you over here, but what we are interested in is this guy right over here. Oh, just a second, there we go. You look at this little formula here in your solution. This is what we are interested in. So your X bar, which is going to be this less than 71.3 value that they're giving us in option B. We have already calculated our mean for X sub bar and our standard deviation for X sub bar. So we already have these two quantities. This one is given to us from the question. So we need to first go ahead and calculate our Z-score. Once we have our Z-score, then we need to use the normal distribution table to help us find what that probability is going to be. So let's go ahead and write down this formula, over on our homework side, and let's take a look at it. So here, we will need to calculate Z equals X bar minus mu sub X bar divided by sigma sub X bar. So like I said, our X bar value is going to be this 71.3. Your mu sub X bar, you can get that from the second question that we just did. So right over here, that's going to be 67 minus our denominator sigma sub X bar is going to be 19 divided by square root of 13. Now, if you're comfortable typing this in your calculator at one time, you can go ahead and do that. Or if you want to break it up into two parts, you can do that as well. So for that, I would say, if you want to break it up, go ahead and do the numerator part first. So 71.3 minus 67, and then you can divide it by the denominator. So if you do the numerator first, you will end up getting, let's see, 4.3. And then if you want to divide that by 19 over square root of 3. Now, if you're going to do it in two parts, or even in one part, honestly, doesn't matter. Make sure when you're typing this in, you're putting these guys in parentheses. Sorry. So your calculator knows which part is the numerator and which part is the denominator. Alrighty, so now that we have our 4.3, we're going to go ahead and divide that by 19 divided by square root of 13. And it's going to end up giving us, let's go ahead and put this guy in here. And this will be your Z-score. So remember, this is giving you your Z-score. And we are going to end up getting 0.81. It looks like 815,993. And this number just keeps going. But remember, since these are Z-scores, we're only interested in 2 decimal places. So we will go ahead and round this guy to 0.8, and that 5 will actually make the 1 go up. So you will have 0.82 as your Z-score. Now, one thing you have to keep in mind is the direction of your inequality symbol. So you can see in part B, they are asking us to find the probability when our sample mean is less than 71.3. So, just as a rough sketch, if you think of this as our normal distribution, our mean will be somewhere in the middle. And so when they're talking about less than, remember the less than is what the table by default gives you. So it already gives you what the less than value is going to be. So all we have to do is get to our normal distribution table over here, find the Z-score and look for, the probability or the area that's associated with this Z-score. So since this is a positive number, positive 0.82, I'm actually going to click on table 2, which I believe is for the positive numbers. There we go. And I don't know if this is going to be a little hard for you to see, but I will guide you along. So we are looking for 0.8 on the left-hand side. So we have 0.8 on the left-hand side, and then this for this 2 over here, we're going to go to the top column and look for 0.02. So remember, you break up your z-score into 0.8 plus 0.02. So this is on the left-hand side of your table, and this one you're trying to bring from the top. So 0.02 will be right over here, and then wherever those two meet is going to be your probability. So looks like it is going to meet right here at 0.7939. So our probability is coming out to be 0.7939. And like I said, this is by default always showing you the area to the left. And so since we have a less than symbol over here, we are good to go. So let's go ahead and close our table over here. And we should be able to plug in this probability that we just found. So 0.7939. Check. And we are good to go. So let me go ahead, clear this up and show you for that part C now. So for part C, they're changing the direction of your inequality, and of course, giving you a different number also. So now we have X bar is greater than or equal to 68.5. So X bar is greater than or equal to 68.5. So same formula, X bar minus mu sub X bar divided by sigma X bar. We have 68.5 minus, again, using these same values from our second question here, which will be 67 for the mean, and standard deviation is going to be, let's see, 19 divided by square root of 13. So let's see what this z-score comes out to be. And again, you can do this in 2 steps, or you can try and do it in 1 step, whatever you're most comfortable with. So subtracting our numbers on the top and then dividing by, let's see, 19 divided by square root of 13. And we will get a z-score of let's see, 0.28464. And again, this number keeps going. So again, we will round it to 2 decimal places, which will come out to be 0.28 this time. So that's our z-score. Now let's see what our corresponding area is going to be. Now, however, again, I'm going to do my little normal distribution over here. Your mean is going to be in the middle. So this time we have greater than or equal to 68.5. So, let's imagine if this was somewhere over here. So we're saying greater than or equal to. So this area. So what's going to happen is, remember, by default, the table for the normal distribution is going to give us the area, which is going to be less than. So to find the area that we are interested in, which is shaded in red, you are going to have to do, because remember, the normal distribution has 100% or in decimal 1 as its probability. So to find this area, you will then end up doing 1 minus, whatever probability you end up getting from your table. So let's take a look at what our probability is coming out to be. So again, since this is a positive 0.28, I'm going to click on page 2 of our table. Remember, again, we are looking for 0.2 on the left-hand side. And I think I'm going to have to move this guy just a little bit more so you can see that table through this mess. Okay. So 0.2 over here on the left-hand side, and then 0.08 on the top. And let's see, where will they meet? 1, 2, 3 down here, 6103 or 0.6103. So this z-score of 0.28 is giving us the value of 0.6103, but this is not our answer. Remember, you got to do 1 minus 0.6103 to find what the area of this red shaded part is going to be. So let's go ahead and do that very quickly. And this will come out to be 1 minus 0.6103. And of course, this will come out to be 0.3897. And that actually is going to be your answer for this part. So that's kind of what we are looking for that area. Okay, so let's go ahead and plug this number in. 0.3897. And remember, they're all asking us to round it to 4 decimal places. So just be careful about that rounding. We'll check our answer and you are good to go. So you can see how this question comes out to be. And a lot of these are going to be similar types of questions. So you just follow the same example and try and see if you can, solve some of those other questions you're coming across. So let's go ahead and clear this. And, if you have any other questions, just please let me know. All right. Good luck, guys. Take care.